Hello all. I've been asked to do a couple of problems out of section 12.2 and I just thought I would send it out to everybody. This is using the first and second derivative and then doing some graphing, which is what we end up doing in section 12.4. These problems are on page 645, and the first one I'm going to look at is problem 49, where I have f of x is equal to 16x times the quantity x minus 1 raised to the third. You need to get some quick information that you should have been able to do from your pre-calc class. My domain on this, since I do not have any even roots or division by x, is going to be all real numbers. So I'm looking at the whole number line for x. Y-intercept is a very, very quick value to get. Remember, by definition, the y-intercept is when x is equal to 0. If you put 0 in here and here, you're going to end up with 16 times 0 times negative 1 to the third, but that doesn't matter because I'm multiplying by 0. So my y value is going to be 0. So I know right now my original function is going to go through the origin. Now the x-intercept, particularly in these problems, since they're already factored, you can find the x-intercept fairly fast. Remember, that's when remember f of x and y are the same. So if y is 0, since this is factored, set your individual factors equal to 0. So x equals 0 and x equals 1. I already knew this one because if my graph goes to the origin, that's my x and y intercept at the same time. But the other one I didn't know about was this 1, 0. So that's just some quick information. Now I'm going to go use the product rule. I noticed some of y'all are doing exactly what the book does. I've just found this process a little bit easier. It's about the same amount of writing, but it just keeps things, I think, a little bit more separated and clearer. So I'll let u be my first factor, v be my second. U prime's not bad. V prime, got to use my chain rule. Remember, you have a parentheses raised to a power. You have to take power times coefficient, rewrite, decrease power by 1, times the derivative of the inside. And the derivative of the inside here is 1. And then I have to do a cleanup. Now, here's my product rule. I have got v times u prime plus u times v prime. I simplify this in that I get all my monomials to the front, all my parentheses to the back. I double underline this because normally you can do what's called factor out. No, you don't have to do this. You can put this whole big mess in your calculator. It will still come out to be the very same thing. But when you've got factors, sometimes it's just a little bit easier to find this information. So if you'll notice, I've double underlined this term, double underlined this one. Both of these have a coefficient of 16 in common. Both of them have a parentheses. This one raised to the third, this one raised to the second. So the most I can pull out is the least amount that I've got. So here's my common monomial, common binomial to the second, and these big parentheses I indicate what I call leftovers. So if I pull 16 out of this one, pull 2 of these out, it's going to just leave me 1, so that's where this one comes from. My second term, if I pull 16 from 48, that gives me 3. The x stays. This whole piece comes out. Cleaning up this back end parentheses, notice I get 4x minus 1. Now I've got over here, notice the factors. I could set them equal to 0 and get x equals 1 and x equals 1/4 as my critical values, or you can graph it. Now this is what I would suggest to find your zeros, because you also are able to fill in your f prime chart. So let me go over and graph this. Let me go to y equals 16 parentheses x minus 1 quantity squared parentheses 4x minus 1. Now, you also might try this line and see if it's not the exact same curve. So let me do zoom 6, see what I can see. Whoa. Alright, since this is within plus or minus 4 of the origin, usually I do a zoom decimal, and that gets me in a little bit closer. Alright, it hits here. Let's go find our 0. So second calc, number 2. I'm going to put, it asked me for the left, so since I'm after that one, I'm going to put an x value to the left of that. So I'm going to type in -1, hit enter. And now I don't want to go all the way over here. I'm going to go right here. It looks like, say, 0.75. You only can surround 1 0 at a time. I don't guess. So 0.25 and 1/4 are the same. So that's what I got right here. Let's go find this other 0. So second calc, number 2. So let me put in 0.75 and 2. There's my other 0. So notice I got the same information. I got it from the graph. So I put my x values down. I know my derivative is 0 at 1/4 and 0 at 1. Now look at my sign chart. This negative I got because to the left of 1/4, all my y primes are below. That's negative. Between 1/4 and 1, my y primes are above. Sign-wise, that's positive. To the right of 1, they are above, so that's positive. So now since this tells me slope of tangent line, a negative means it's coming down. 0, we are leveling. Positive, we're going up. 0, level. But another positive means I keep going up. So I've only got a min. Notice it's coming down, leveling, going up. I've got one min. To find my min, remember, store in 1/4. So let me get out of this. So 1 divided by 4, storing for x. I'm going to type in my original. So 16x times the quantity x minus 1 raised to the 3rd. And that's where I got that. So my minimum is a negative 1.6875 at x equals 1/4, or that's my coordinate point right here. I'm going to have to hold on to that. That's one piece I'm going to have to use. Now, second derivative. Another reason I like factoring is that I don't have a humongous mess like this. I'm going to do the product rule again. This is going to be u, this whole piece. This is going to be v. So there's my u, my v, my u prime. I have to do my chain rule. So 2 times 16 gives me 32. Rewrite, decrease power by 1 times derivative of inside. This is my cleanup. The derivative of v is just 4. And now I'm going to put it in the appropriate place. So there's my v. Because it's a binomial, I use parentheses, times u prime plus my u times my v prime. Clean up, and here I go with my double underlines again. I'm going to look to see what I can factor out. A 32 is common to both. Notice I've got 1x minus 1. I've got 2x minus 1s. So I'm going to pull out one of those. So in my big parentheses, I'm going to write what I've got left over. So if I pull a 32 out of this one, that one comes. The x minus 1 comes. So all I'm left out of the first term is 4x minus 1. Second term, pull out a 32. 64 divided by 32 would be 2. Since I've got 2 of these, I'm pulling 1. I've got 1 left. In my little scribble here, you can't see. I usually do this so I don't have to rewrite it all over again because I just need to simplify this. I distributed the 2. So I've got 4x plus 2x gives me a 6x. And I've got a negative 1. Minus 2 gives me negative 3. So if you set this equal to 0, there's x equals 1. This right here gives me x equals 1/2. Let's go back to y equals. Let me type this one in. I've got 32 times the quantity x minus 1 times the quantity 6x minus 3. And let's see if it does look like it hits at 1/2 and 1. There's 1/2, there's 1. If you'll notice, you have to look real quick. Let me go back. I'm going to turn it off a second. Because now, when I go back and turn it back on, watch how it enters. Now, it did that pretty quick. But it came down and then went back up. Another way you could look at this, if I do second calc, let me try value. I'm going to put in an x value of 0. I want to see what my y double prime. Y double prime is positive. So anything to the left of this 0.5 is positive. So that's where I came up with my positive sign right there. Between 1/2 and 1, let's try 0.75. Should be negative. Yep, it's negative. Remember, this is double prime, so it's negative, indicating it's down here. So let me put in a 2, because I want to see if this is right. My plus on the other side. Oh, it's just a positive 288. So now on your second derivative, remember, use little tiny baby parabolas around your sign. A plus means that section of the curve is concaved up. A minus, it means it's concave down. And a plus means it's concaved up. So now I know 1/2 and 1 are my inflection points. And like before, let me move this up a bit, take this back to the original. There was my original, so let me type in 0.5. I do second, enter, second, enter. That repeats. There's my -1. And if you put 1, well, if you put 1 in here, that's going to be 0. So this whole thing will equal 0. But we can go ahead and store. Again, do second, enter, second, enter. Okay. So now, remember the values I had. One value I needed to keep was this minimum. So at 0.25, I'm going to go down -1.6875. Notice I had to really go in on this because my numbers are real small. So here's 0.25, right in the middle of 0 and 0.5, and I estimated. Now -1, 1 0, oh, stars. That's this thing right here. Remember, the slope of my tangent line. This is 1, 0 right here. This is 0.5, -1. Brother, that's that point. And that's one of my, remember, my concavity changes. Now, from -infinity to 1/2, notice the concaved up. Do you see the curve up? From 0.5 to 1, it's concave down, which is what that's indicating. And from 1 to infinity, it's concaved up. Here's my minimum. There's my x values. So guys, just with really 1, 2, 3, 4 points, this should be a very, good picture of my graph. So I'm going to go to y equals. Let me clear this off. Now why I like second enter is because since I have used the original to find out my y values of my minimum y and at my inflection points, if you do second enter, it will paste it in. Just saves time. Now remember, my picture looks like this, so let's see. Now I know the window right now is at zoom 4, which is a decimal window. Let me go in and change it similar to my window. So let me do a -2 to 2. My scale is 0.5. My y value is -2 to 2. Okay. not bad. It comes down, bottoms out. There's that curvature going down, and then at 1, 0, it's concaved up. Okay, now this was problem 49. I was also asked about problem 61. Problem 61 dealt with natural logs. First, find some quick information. If you remember from your pre-calc class, natural log of x, you cannot take natural log of 0 or natural log of negatives. So my domain is going to be restricted from 0 to infinity, not including 0. Y-intercept is when x equals 0. Can't in this problem, so I have no y-intercept. X-intercept is when y is 0. Now I did it by hand, but then, guys, we can also do it by calculator. I'm letting you go that route. But if the answer in the back is this, you have this in decimal form, put their answer in the calculator and see if it jives with yours. So I added 4 to both sides, divided by 2. Remember, I have to get this natural log of x isolated, and then I had to go to exponential form. The base for ln is e. Remember, this is my exponent, so e squared equals x. That would be my x-intercept. Now I've got either solve by hand or use your calculator. I'll leave that up to you. Vertical asymptote, remember, I can't use negatives for x or 0, so if you remember about your natural logs, they sort of snuggle up to the y-axis, and the y-axis is x equals 0. So if you don't remember this, initially, then go to your graph once you get more information down and try to get some information that way. So let's go get our first derivative. Derivative of a constant 0. This is how I do the derivative of natural logs. I take my coefficient, there it is, times, I see ln, I draw a line. Whatever I'm taking the natural log of goes denominator, and I look here, right here, to answer the top. The derivative of x is 1. Clean this up, it's 2 over x. If you graph this, clear that out, 2 divided by x, let me do a zoom 6. Now, to the left of 0, remember, can't have division by 0. To the left of 0, it is negative, but remember, this particular problem, I'm concerned about 0 to infinity. So I'm ignoring that. Can't use it, so I'm not going to worry about it. But to this side, if you'll notice, my y prime values are positive. They are above. So that means my original curve is increasing on its whole domain. Now, let's go get second derivative. So there's no max or min, so that's all I can do with that one. I'm going to rewrite 2 over x as 2 times x to the negative 1, because it's easier to do that instead of going and doing the quotient rule. So negative 1 times 2 gives me negative 2, decrease power by 1. So I end up with negative 2 over x squared. So I've got negative 2 divided by x squared. Okay, both sides, 0 is not defined, so that's where that came from. Remember, because I'm playing with natural log, can't use this side. This side, it's below. These are double primes. Remember what we put in. So it's negative, so that means it's concave down on its whole domain. So I really don't have any points. So normally, then, what I do is I go, let's go back to y equals, clear this off, put in the original, and let's ask it to graph. I've got some points. Do you see some points here? But what I need you to see is this thing is increasing on its whole domain. The curvature is down. So I'm using this information, but I'm sort of restricted. So if you go to second table, see anything 0 or above, I've got errors because I can't take natural log of those values. So 1, -4, can you see my dot? The rest of these points I sort of estimated. Now, let me go back to my graph. I'm going to go find that 0. Second calc, 0. Let me put in 5. I'll put in 9. Don't guess. 7.39. There it is. So that's why I've got my little point right there. But guys, again, I'll take either one. It doesn't bother me at all. But sometimes the derivatives will give me a lot of information like they did in the first problem. Sometimes it tells me about the graph, but there's not enough information for me to go and just up and graph it. So I got to go get points. So sort of similar to what we did in pre-calc. So I hope this helps. Thank you.